Okay, our project was infrared music signal transmission. Initially, we had a major project change in the middle of the semester due to some technical difficulties, and we changed the entire direction of our project. What we initially were doing was trying to use infrared signals to control a car. Using little transmitters placed in a predetermined configuration, and make the car follow a path based on infrared signals. Due to those technical difficulties, we decided to change our project, and we just decided to transmit signals using infrared frequencies. So, this is what we came up with. And this picture right here is of infrared LED that's lighting up, and we used a cell phone camera to detect it and take a picture to see whether or not it was on. So, for our introduction, everyone here listens to audio devices, whether it's an iPod or a CD player or anything of that nature. So, our idea was, why not make something that you could even, anything with a headphone jack, you could turn it, use it, you listen to it wirelessly. So, in reference to comparisons, cell phones have Bluetooth, but, let's just say I have a CD player that I want to listen to wirelessly. My CD player doesn't have a Bluetooth adapter, so that wouldn't be possible. But with our project, anything with a headphone jack, you can listen to it wirelessly. And for this right here is for those old school people that want to listen to 8 tracks or cassette players. They can, once it has a headphone jack, it'll work with it as well. So you can connect it to headphones, speakers, or any other listening device that can connect to a headphone jack. And So, why infrared? So, Bluetooth is very popular, very innovative, but it's very complex. There's a lot of programming involved, and it's just, programming is not our area of expertise, so we decided not to go that route. And it's also lower cost, because the only thing that we needed for this project was infrared LEDs and headphone jacks, and a 3mm headphone cord. That was about the only thing that we bought. Everything else was in the lab. And it's more versatile than Bluetooth, because Bluetooth needs a Bluetooth adapter for you to connect to. And it's just more simple and it's more user-friendly to use infrared than Bluetooth.
Okay, so here we have the transmitter schematic, which is basically here at the input. You have your stereo signal coming in. We're mixing the left and right inputs so that we can get a mono signal. That's coming through our 82 ohm resistors. And we have a capacitor right there of 1 micro. That's basically taking out any DC that's coming in with our signal to go through our op amp. We have here at the negative terminal of our op amp just a basic voltage divider. And then here we have our feedback loop, which gives us our gain of about 5.7 because it's a non-inverting amplifier. And you have C5 right here, which takes out the DC that we introduced. And you have our load resistor here of 100 ohms that will help generate current to go through to turn on our IR LEDs because they need a sufficient amount of current. We also have the 360 ohm resistor here also just to pull current to turn on our IR LEDs and our resistor to ground. And basically, through all of this, we have our input signals coming in, and we're transmitting it through our IR LEDs. So that's here. Then we have the receiver schematic.
So for the receiver, right here, you have the input to the circuit. We have our infrared light coming in here into our phototransistor, which then sends a signal through this potentiometer here, which controls the volume of our receiver. So you don't have to get up and go to your device to change the volume. You can change it right at the receiver, and it takes that becomes the input to our amplifier here. This is a LM386N-1 op amp, which is, we chose this this op amp because we needed enough current to drive a speaker or to drive a headphone, which is to drive headphones. So regular op amps don't give out enough current. We needed about, what was it, 20 milliamps, 20 something of that on that order. So here, this configuration was in the spec sheet for the device to get a gain of 50 dB. Basically, it's just a run-of-the-mill amplifier. We're just amplifying the signal that's coming in here. And this capacitor is here just to block any DC from going into the load that would damage our speaker or damage our headphones. And this is the supply rail for the op amp. And we set it to oscillate between 0 and 9 volts. And the rest of the elements are just for stability and for the gain configuration. So, and this is the load here. This is where you would plug in your headphones. This is where the headphone jack would be connected. And then once you connect your device, it would become the load.
These are some challenges that we encountered while building our circuits. First off, alignment of the receiver and transmitter. The LEDs have to be in line for it to actually transmit or to pick up the signal at max potential. Also,